Next up we have lists. So we've seen lists before, and we'll revisit them here. And then there's a little loop element to lists as well. That's kind of cool that we'll see. So typically lists do not have different types of elements in them, but we can. So we can make a list that has an integer, a string, and a floating point value. Lists have this function that we can use called len or length, which returns the number of items in the list. So in this case, the length would be 3. And then, as we saw before, we have indexing by position. So we can use L, and then we use these square brackets, and that gives us 0 would be the 0th element of the list, and you guys are familiar with that now. And we can also slice the list, so we can go from the start of the list, which would be, there's an implicit 0 here, but we don't need to type that, so we just type the colon and then -1. And -1, remember, is the last element in the list. So if we go from the start to the last element, we're going to go up to, but not including that element. So we're going to get the first all the way through the penultimate, or the second to last element in the list. Now, this is now at least the third example of this plus sign doing something new. So remember, with it does the normal math thing. With strings, it will concatenate strings. With lists, it will concatenate lists, but that does a slightly different thing, because although under the hood a string is basically a list of characters in a certain order, and lists also have a particular order. This is adding a new element in this case, to the front of the list. So we have the list, or to the back of the list rather, because of the order. So if we had typed this this way, it's going to give us the opposite order. So this plus sign concatenates lists, just like concatenates strings. But we're not changing the original list. That object L, that list, is still the same. Now, we can append a string to it. So this is appending a new element to the list. So now we've changed L. When we type L, we have now added this 4th element to the list. We can also remove elements by using this function called pop. So this will pop element 2, and that will be saved. So now we've removed this element, and now this knee that we added is now no longer element 0, 1, 2, 3. It's now element 0, 1, 2. Question? Yeah.
So you want to add the object at any place of list. Is that into that?
Yes. So you can. Let me see if we have anything in here. You can reassign a list to add something in the middle. I believe there's. Let me try this. Let me see what the options we have. To insert, yes. Yep. So this would be insert. So let's just check that L is still what we think it is. Okay, we're going to insert 2. What did I do? I typed some keyboard shortcut that. All right, I'll figure that out. Anyway, we have line numbers now in our cells. Okay, but the point of this is that yes, we can insert a new element here. So we're basically giving the index, which would be 0, 1, 2, and it will insert that. And I believe see if this works. Okay, good. Okay, I believe I can add multiple elements here. Okay. So that adds them as it as a list. I don't know if there's a way to add. Well, yeah. So this is an option. Typically, it happens, but it doesn't come up a lot in my experience. You're more likely to maybe add stuff to the beginning or the end, or just to go through a list and not change it at all. You can also say, let's say we didn't like this. And then we can reassign, right? That's another way. So instead of adding a new element, we can just change the one that's already there. So if we have a list of strings here, we can sort them. And that's done in place. So now this list is sorted alphabetically. If we want to reverse the order, this is not done alphabetically, it's just done reverse, but since it already was alphabetical, it'll sort it, or reverse the order, rather. And we can do nested lists. So we can do a list of list, which is kind of like a matrix. And so this list M has 3 elements, and each of those elements is a list. And so if we want to get this middle list, this would be using the index 1. And then if we wanted the last element there, we wanted this, basically we wanted to go row 1, column 2, which would be 6. We can use this bracket notation. What we'll see with data science and Python is we can use pandas data frames to do a lot of this for us. We can still use numerical indexing, but it's a lot more powerful in the way that it handles big data, basically. A couple more things. So let's make. So here's an example showing this range function again. And what I've done was I've just converted it to. So when you type range 10, it gives this range object, which is sort of like a list, but it has to be technically converted to a list to see it that way. So we just said we've taken that output and then use this list function, which can turn anything that can be rendered as a list, it will try to. And so now we have this list of integers. And so a few more indexing things, which most of which we've seen already. So we can go from the start to the up to, but not including the 5th element. We can start and get the same thing this way. We can count. We can start from reverse, or start from counting from the the end back, so we use negative indexes, and then we can use just basic indexing like this. So we've seen all that before. Now the sort of cool new thing with lists that we'll cover today is something called list comprehension, and this is sort of somewhat unique to Python as far as I know. At least I hadn't encountered this until I started using Python. And what it does is it allows us to create a list using a for loop in a single command. So if we recall, our M is this sort of matrix thing, and this list of lists. And we're going to say, the way that we read this is, we have this thing in brackets here. And we're going to say, for each row in M, and this word row is just a variable. We could call this foo, we could call this Bob. It's just a variable, but but basically it means for each element in M. So M is this list, and the elements in the list happen to be lists, but right now that doesn't matter. Saying for each row in M, or for each element of this list, I'm going to get index 1, which is the second element of that list, and I'm going to store that as this thing called call2. So what it's doing is saying, and again we could call these, we can call this anything, and it will still work. So for each element in M, we're going to do something with it. In this case, we know that it's a list, so we can get index 1 from that, which would be this middle element. So let's give another example. So here we're going to say and we kind of read these backwards. So for every row in M, we're going to take that row, get index 1, and add 1 to it. And this whole thing is going to be a list, and that's going to be stored as M2. And then, so we've taken this, basically we've done the same thing we did here, except for now we're adding 1 to each element. Another example is we can say, we can kind of chain these operators. So we're saying I want to get for row in M, we're going to get the first element, but only if that value modular 2 is equivalent to 0. There's a lot going on here. But basically what it's saying is for every row in for each of these rows, we're going to get this middle element, and we're going to include it if this middle element, if basically modular arithmetic, this %2 says if the remainder of dividing that thing by 2 is 0, then it will print it out. So we're only getting these two elements here. Before I go further, you guys get the general idea of the list comprehension? I realize there's some funky math I'm throwing in here, but so there's we'll see some other examples here. So for here we can get the diagonal of a matrix, basically, which would basically is saying for I in this list 0, 1, 2, give me M. Again, M is this thing here. Give me M 0, 0, which would be this thing, 1, 1, which would be this thing, and 2, 2, which would be this thing. So it's going to, and it's all. This only works if the whole thing is in brackets, which is going to give a list at the end of the day. So it's going to give us 1, 5, 9. Okay, kind of switching gears a little bit here. We can remember that a string is basically a list, so we can say for C in spam, so we can C is like a character. Again, it's just an arbitrary variable. For C in spam, we're going to get C times 2, so it's going to give us the double character. So again, it's going to be a list. So for each element in spam, it's going to be S. So S times 2 is SS. Then P times 2 is PP. A times 2 is AA, and M times M is MM. And then it gives us this list. Or this is a mathematical example for X in this list 1 through 5. It's going to give us the square. So X squared. Now, what this is doing, this last command, and this is a little closer to what a common example you might use in a program, is it's giving us a list of squares of the values in this list from 1 to 5. Now, what we could have done was we could have said, okay, first you have to initialize this list. So I'm going to say squares is this empty list. And then for X in 1 through 5, I'm going to take that empty list and append X squared. So this gives us the same thing, but this took us 3 lines of code, and we had to initialize this thing and all that, whereas with this list comprehension, we could do it all in a single command. So if this list comprehension doesn't feel right to you, or it's just weird to you, you don't have to use it. You can use a traditional for loop like you would in any other programming language. But once you get the hang of it, you realize how handy this can be and how you can do a lot in a single line, and it really makes your life easier.